Hello students, welcoming you all to the MCEN 3003 lab sessions. As per the outline, we can see that there are 5 lab sessions to be conducted. So the fifth one is basically the assignment. So the assessment on the CAD/CAM lab is a mechanical part will be supplied for you all. In that case, you will have to do the machining and generate the CNC code. So we'll start the lab sessions. I hope everyone is quite a bit of familiar with SolidWorks. So now the first lab sheet. It says that it has given machining CNC machine series, a code. So the first line, of course, starting with this word start, and then the percentage symbol, and the program needs to finish with the percentage symbol. So the line 35 here, of course, shows about the works reference. So we'll go to the line 35, which is this, and here this is the actual code, and this is the line number, and here, of course, this is the coordinate at which we call the datum of the bench wise, or the wise, the position of the bottom corner of the bench wise, right? So that's with the works reference allows a suitable point on the workpiece to be 0, so that will be basically the datum. So, and it should be the bottom left hand side top face. So you only need to include G92, and the N35 is not needed, right? So this is basically it, and you can save it to a Word file, right? So we are doing the SolidCAM, whereas the Curtin is conducting the AlphaCAM. It is quite a bit of similar. It's a similar software actually. There's but the SolidCAM is, of course, yearly updated, right? So we'll move on to the next lab sheet. So here, as you saw before, you did see the codes, the G codes actually. So there are letter numbers as well, and the M codes. M codes is basically definition, like the features that you will be including or you'll be activating, right? So for example, the coolant, right? And these letters, actually these are the definitions of it. You can go through them. So before we did refer to G92, which was similarly reference coordinate system. So this is the code that is used for setting up the work coordinate, right? So we'll move on to the next sheet. So this is what I said before, right? So this is the bench wise. So here it is the starting point or the datum point. So when actually if the cutting tool is here at this place, so these are two sectional views, okay? So this is the top view, and this is the cross-sectional view, right? Side view. So here to get this cutting tool to this position. So this is the datum surface here, right? So it has a Z of minus 355. That means it has to come down minus 355 and move Y of minus 147 and X 460 to reach this point datum, right? So that is what this means. So if you are making part, it's imperative that you first check the position of the vise, as it may differ due to other students using the machine. So this is a preliminary step or the precaution step that you need to start on with, right? So basically you will be given, so at the end of this like the assignment, for the assessment you will be given such details like the drill holes, the tools that need to be used, the material that the part is made of. So those details will be given for you, right? So this is one of the things. Actually, starting with, you can see this initially this part will be a stock metal block, and finally it will be going through this procedure or the process coding. Likewise, the machining will be done to get the final product as this, right? So you can see it has been selected pocket contour here, right? So there are various operations that needs to be done, right? We'll move on to the next. So in the industry, of course, when you are to machine, there's obviously a planning sheet that you need to follow. So that actually, to get the final outcome, for example, if you get a stock block, you have to first machine face it to face, and then to proceed with the pocketing or the drilling. So before drilling as well, there's a particular process that needs to be done, which is called the spot drilling. That is to have some spots or punches at the drilling places so that the drill won't slip either side, right? So basically this is the operation schedule, right? Guys, this is another CNC code, right? You can see this will be the preview of the machining, right? It will be shown in lines, right? So starting with, this is called a profile. This process is called a profile, right? So and then you can say this is a pocket, or this is end milling, right? End milling pocket. Here as well, it's a pocket here, and then it starts to drill. First of all, spot drill it, and then the drilling process. Right, so this is the final output. Okay, we'll move on to the next. So first exercise for the top clamp plate shown on figure 1. right? So this is the cross-sectional view and the top view. So the material is given, so it is a mild steel. The machining start position should be the bottom left corner, which is, if you get the top view, it is the bottom left side corner, right? So, and the component clamped by machine vice with top face of the component being 20 millimeter above the vice jaw, which means that if you get the cross-sectional view, you see that it should be 20 millimeter above the vice jaw. That means that the vice jaw will be, I have drawn this line, right? So below you will find the vice jaws, right? The above there are 15 here and 5 here, which means 20 above. Okay, so the available tools are given with the tool position and tool diameters in millimeter, end mills, slot cutters, center drill, right? So 10 drill and 40 drill, so likewise. So these are with millimeter dimensions, right? It has said that available tools are given with the tool position and the tool diameters in millimeter. Okay, so through the schematic diagram it can be seen that here, of course, there are 5 holes with 10 millimeter diameters, middle slot here and a pocket here, right, and the profile rounding. Okay, so we'll start with the SolidWorks drawing first. And always make sure when drawing, use the simplest way that you can complete the drawing as soon as possible, right? So select this. So the dimensions are 100 square, so make sure the units are in millimeter. Okay, metric 100, and then it should be a total of 10, right? This area, right, this part below, so it should be 10, should be extruded 10 millimeter, right? Okay, and then above that there's another sketch, so that we have to have another plane here, and you can see the plane is over, so we have to coincidence it, right? So coincidence, and then you have to sketch it again. So the area for this is you can see it is 40, 20 and 20, which means 80 here, right? 80 square, alright, and then there's one more thing to do. You can see there's a radius of 15 millimeter fillet, right? So you have to have the fillet, and here it's 15. Okay, then we can extrude it. What is the height? 15 millimeter. Right, so all set. And now for the pocket in middle, right? So we'll start with the circle here. It's R20, right? It again, you have to have another reference plane here. Coincidence. It was R20, which means 40 diameter, right? So I have to cut this. Well, this too. What is the height? It's 5, right? So before cutting, right, we can directly cut it as one. So we can have here, so what is the size of this part? It is, how much is it? So it is given 20, right? So we can have a triangular, yes, and it comes to this. Right, so having that, we can use the trimming tool. Right, this and this, right? So see whether there is any curve here. No, it directly joins to the straight line. Right, so having that, we are ready to go for the extrude cut. So one more thing, here you have to trim this part as well to make this one feature, right? So it's 5, right? Okay, that's done. So in the same plane we can draw the rest of the in the same plane we have to draw the next drilling, right? So there are 5 drills, 10 millimeter diameter, and it should be whole drilled through fully, right? So how are we going to draw this? The easiest way is that you can just draw a sketch of a box for this here, likewise in the SolidWorks. So what is the height? 50. The height of the box is 50, and the width is 50 as well, right? So 50-50. As the construction box you can have here. So this is really using less time, right? With less time you can draw, as it's really hard to plot to figure out where the circles are, right? So then of course now we have drawn the fish, so now we can have this as the reference, and then through the hole wizard you can select the hole here, and then it was 5 10mm drilled holes, right? So it's 10mm, right? And the positions you can give it, first of all click on the part and then select the centers, right? So simply the part is drawn and completed, right? So you can hide this, right? So the part is done, right? Okay, so now we have the part with us, so make sure you save it. And then we'll start on with the solid cam, right? So this is the machining process now. Start new, and this should be milling and not mill turn. It should be milling, right? Actually this process, SolidWorks and SolidCam, rather than SolidWorks, SolidCam requires a high power of your machine, so make sure you run both these as with administrator rights, right? So that this would not crash in between, right? So starting on with create a cam part, we are making external parts rather than within the SolidWorks, right? So make this as a external project, and you can browse and select the save location, right? Top clamp. So units metric, and you can use the model file director here so that it will be directed straight away, right? So now next is that we have to select the CNC machine controller. So each and every machine is unique and it has different controllers upon the brand, so there are so many. We'll go with the first one, the Fanuc controller. So and then we have to go with the coordinate system, right? So as you remember, in the bench wise, of course, we selected the position. It was the the left hand side bottom corner, right? So it should be here, right? When it comes to the stock, it should be right over. Okay, so we have to first select the model, right? So you can see the box is selected, and there's a stock, the coordinate box, right? So you can then pick the origin, right? You can take it to the top, right? So make sure when you are doing this, the coordinates, the axis should be z to the upwards, and then y in like the opposite facing you, right? And the x to the right hand side. Okay, so now we are done with the coordinate system, right? Okay, okay, alright. Now we have to select the stock. Stock means the raw material iron bar, which means the mild steel bar for this case. So when we get the block, it is not exactly the dimensions of this, it should be more than the dimensions of the final component, right? So it is, you can select whether it is a cylinder or anything. So it is a box here, right? So relative to the model, so now you have to select on the click on the model, and then you can see we have predetermined size for the stock, right? So better you also follow this, right? X2, y, x minus 2, y2, y minus 2, z plus 2, and 6. So these are the sizes that are given according to the coordinating system, right? So you can see in y and z base it is 2, plus z base is 2, and minus z is 6, and then x plus is 2 and x minus is 2. So likewise in the y direction it is 2 and plus 2 and minus 2, right? Okay, then we are ready to go, and we have to add this box to the CAD model, right? So now there is one more thing that needs to be done. Now if we are to machine, the coordinate will be coordinate origin will be here, but we need to take it to the position of this, actually to the position of the stock mild steel, right? So it should be here. So how are we going to take this? Okay, so we will be going back to the coordinating system, right, and edit this, edit the coordinating system. Okay, just select the face again, right, and you have to pick the origin as this, right? so it directly moves to the top place. So now we are ready to go. So there is another way that we can do this actually. It is by, you can use this shift place, right? Or when you are actually initially determining the coordinating system, you can modify this by x2, y2 and z2, right? So you can have this, enter values this, or else you can do as we followed in this way, right? So now it's, or let's come down again, wait, pick the origin. So this is kind of easy rather than that, right? Either way it's correct. So this is how it should be before starting the machining, right? Okay, so now the settings are okay. Now we are to go to the operations. Setup is done. You can see the setup is here, right? So now the operations. So starting how to do the operations is that you can right click the operations, add an operation here, and first of all, right before that, here you can see now we have to first cut this part, right? Now the machining will start from top to bottom, not from bottom to top. Since the coordinates are placed at the top, so it will be now if like actually the machining can be done only from one way, either top to bottom or bottom to top. So it is the matter of placing the block actually as per your requirement, right? So we will be machining from top to bottom first, and then rotating the part and machining the end, right, or the bottom. So we'll start with this. Right, so first of all we have to face this part, top part you have to face, right? Add milling operations, face, so here of course they have given end mill, so we can use the end mill for facing as well, right? Or else there are facing tool as well, right? So only the available tools are to be used in this, right? So the end mill can get the highest or the maximum diameter to face it within a short time, right? You can select either one of these, but it will take some more time to face, so better to go with the highest diameter, right? So it's 40 millimeter, right? Right, okay, then the coordinating system, it is a face mill, right? So that is okay. And then next you have to select the tool, right? So here add a milling tool. So this is a face mill. Now we are not going to face mill it because the tools that are given is end mill, right? End mill, slot cutter and center drill, right? End mill, you can see the picture of the tool here. right? So the end mill here, the diameter is 40. That is what was given here, right? I'll take the highest diameter, right? So it's 40. So when you enter 40, all the other things will, or the other dimensions will change according to the requirement, right? So you can select the number of flutes. I have selected it as 2. So basically these are predetermined ones, right? So you can select the holder, right, coolant, and those are actually not needed for this operation right now, right? For this actually the assignment as well, the coolants and all the other factors are not that necessary, right? It's only the machining that is going through. So this is okay, you can proceed. Okay, enter, and then the levels, right? When it comes to the levels, this actually by target it assigns it, right? So you can give it by user define, right? The upper level you can select it as this, right? And the upper level is actually the coordinate system where the coordinates are there, and the depth is this, right? Now this can be, so you can select either equals up down, right? So it will be going at equal steps, so you can use 2 steps, or at 1 step you can do it straightly. It will go with 2 steps to be on the safe side. The technology, so this is a hatch movement. The hatch movement, you can see the contour will be like this, a loop. So actually this is the motion of the cutter, right? Contour, 1 pass, right? At a single pass it will do the task, or spiral, right? So we'll go with the hatch, right? Go with this equal step over tool diameter. So you can select the finish, right, to get the to directly finish the do the finishing as well, actually, right? So there are 2 operations that can be done actually. When machining, we normally do a rough machine first and then go with the fine polishing or finishing, right? Okay, so these are okay, right? The link, so the lead in here, a lead in is that where the tool will be entering the bench vise, the vise or the stock, right? So you can select as a tangent, right, or an arc, right? So we'll not have it here because this is a facing, it would directly lead in, right? The motion, it's, so the defaults are okay, right? So now we can calculate, right? Save and calculate. So now you can see there's the machining, sketch, right? Okay students, so we'll simulate this. So calculate, right, and then simulate. So here of course you can use the option as show rest material, right? So initially we can see the stock, which means a mild steel block, and then we can reduce the speed or increase the speed. So I'll reduce the speed so that the machining can be quite visible, right? So it will be like this. So if we use solid verify, right, we can see that the machine itself does the machining, right? So in the rest material we can see now actually the part is visible now, right? So from the top of course, like the red color is the unwatered or the chipped parts, right, or the removed parts, and what we need is the part that needs to be cut. So what we design is basically being cut step by step. Okay, so now the first facing is okay, right? Now we have to move on to the top part is okay. So students, next one of course we have to machine the profile, right? So in this we are going to the operations as a profile, right? So the coordinate system, so we have to create new. Since the operation is different, we have to give a separate geometry, right? So each and every operation we have to, each and every different operation, right? Facing, contour, pocket, so we have to give different geometries, right? So the geometry, I'll explain what the geometry is, right? So here of course now we have to machine this part, right? So normally we are to machine in a clockwise direction, right? So next we are to select the tool, 20 in middle, and then the levels. So by the target of course it has already selected the levels, so it is fine. So here we can see the geometry now. Now the tool is this, and it will be traveling out from the part that we need, right? So this is, it will be cutting the outward from the loop, right? So it should not be right. If it is right, it will cut the inner, right? So it should be left. Okay, so that is fine. So that's the geometry. So we can have the finish passes here, and we can have one step down as well, right? Clear offset is that we have to cut, if you get this, we have to cut from here to this end, right? There can't be material remaining. I'll do this the first try without a clear offset, and I will show what the result is. So the lead in and lead out, you can have it as a dark, right? So it will lead in, it will come into the machining as an arc, or you can defer it to a tangent. You can select either tangent movement, either movement, right? So we'll go with an arc here. So one more thing, that ramping means that starts at the actual starting point, right? So the feeding, right, or direct feeding or rapid feeding, like straight into the machining, or slowly into the machining, or diagonally, or helical, right? It is called ramping, right? So we'll go as feeding, right? So we'll calculate and then solid verify. See, now you can see that there are remainders, right? So that this is why we need to have offsets. By an offset, this will cut the entire part without any remainder, right? So in the rest material you can see that there is at the edges, right? So the silver part is the component actually, right? So we'll go back and have a clear offset, right? So the offset, you can click the offset, right? Click this offset, and then you can click this point, which is, I should show you from the top view, right? This point, because the remainder is here, one is here, one is here, likewise, right, at the very end. So having this corner, right, so the center point is okay. So picking that point automatically gives a value. So we have to include a step over. Step over means that the tool will be, now since the tool will be rotating in this path, right, at the closest point to the boss area, right? So from that point to here, the total tool length would not be sufficient at the corner. So we'll have a small offsetting, like the first pass will be going closest to this boss area, right, and the second will be with a small offset, right? So anyways, that is called the step over. So the step over needs to be a value. Once we have given the offset, it should be a less value than the offset. So we'll go with 10 here, right? Oh, 15 is fine, right? So 15, then so we can calculate and see whether it's okay. Alright, it still goes down, right? Let's see why it is. So the reason is that here we have selected step down as 1, which means that it will be going another finishing pass, so that's why there's a small there's a bit long process, right? So we'll omit that. Okay, we'll make it 0 and we'll have this. So the step O I have increased to 20 here, right? So now we can see, right? Fine, done. So the rest material is now it's fully done. Okay, so next of course we can move on to the now this is done, right? So we can then cut the pocket over here as the next operation. So students, we have to cut this pocket now, right? So operations, pocket, and the new coordinate system, geometry, right? So having this, tool. Now this can be done by a slot cutter. You can see 47, 15 would 15 and 10. 15 would be ideal for this because like the spacing between this area is 20, so 15 tool is more than enough for machining this part, right? So we have to include a new tool, right? A slot mill, and then so the depth is defined by the target itself. And the geometry, we can see the geometry is done. So the shape would be a contour, right? In a shape of a contour, and we have to offset the finish, do a finishing touch for the wall and as well as the floor, right? So now flow set is not correct for finish, which means that we have to give a, as we have given a wall finish 1, offset for the flow should be given a value, right? Seems okay, right? So that part is also done now. So now we'll move on to the drilling, right? Operations, drilling. So as you can see, there are now the drill holes are, there are 4 drill holes in this plane, and there is another hole in this plane. So first of all we have to assign this plane and then go to this plane, right? Because they are in 2 heights. right? Likewise, can select, would name as spot drill, right? So then alright, keep it as drill, right? And we'll select, now we have given in this sheet a center drill only, right, with 10 millimeter and 40, right? So we'll have the 10 millimeter drill, right, drill bit, it's done. Of course, now you can see, if you give by user defined, the upper level would be this, right? So to have the spot drill is just only a small punch, right? So we are not actually drilling it, it's only a punch that we give using the drill bit. So the upper level is that, and the drill depth, since we aren't drilling, drill depth as well would be the same point, right? So now we are to give the diameter value. Now if we are to give now if we are to use the cutter tip, right, we need only the top part, right? So if so, we can use the full diameter or diameter value. Let's try with the full diameter, right? So type of drilling is drill, right? Right. As you can see, there is a small punch, right? There's a small punch given to the 4 holes here, right? So the punching is done now. Spot drilling is done. So for the same, we can have copy and paste, right? You can copy this and paste so that you don't need to assess it again, right? So the thing is, you can have this and edit, and so this is a simple way. So the geometry would be the same, right? The tool will be the same. Now the milling levels would be differ, right? So the starting would be this, and the drill depth would be up to the end, right? Full diameter, right? Full diameter in the sense it will go up to here, right? If it is up to the cutter tip, right? Full diameter actually would be this area, right? You will see, right? Okay. Now the drilling was done. Right, now we can see below, because like below we need to face. Okay, so we need to go to the solid address material. You can see it has done the drilling, right? And we have only one set of drilling left. Now operations, drilling, now the new coordinate system, and this is the right, so this is the only one that needs to be drilled. First of all, it should be spot drilled, right? You can use the same tool, right? Levels by user, the upper level would be this, and the lower level as well would be this, right? So the full diameter, drilling, so this is okay. Right, so we have a spot for that as well. Now we can copy paste this, right? Copy and paste, right? And start editing. So the geometry would be the same, tool is the same, right? Levels will be differed. Drill depth would be full diameter, right? So that is done. If you see from there, it has gone to an extent of the bottom, right? So we'll machine the opposite side and we'll see how the drilling has been done, right? So this is okay. Now the drilling has been done. We have to now turn the part. Now in the vise, of course, we have to switch the part, rotate the part, and have the bottom side facing top now, right? So operations, so it will be a facing, right? So now you have to have the have a new coordinate system, right? Now as you see, this is the coordinating system we should take, or this, right? We'll take this, right? So add a new coordinate system. Remember, when you are rotating, you have to have a new coordinate system, right? Pick the face, align it to the datum of the vise, right? So picking that and then pick the origin as this, right? So it is okay. Now we have the new coordinating system, right? So here we have selected the second position, and now it's a face mill, right? the tool, we can select the first tool that we used, the 40, right? Upper level is this, and the face down level is this, right? And S2 equals step down, so we can use the hatching or one pass. We'll use the spiral, right? Flow offset is 1. We can use the leading as tangent and lead out as tangent, right? So the drill, of course, here there's a small error that has been done. So this drill should penetrate, right? So we'll see what was the error, right? So the facing is okay now, right? So drill this. This was right. What was the issue was it was selected as the cutter tip. It should be full diameter, right? Now it should be okay. Yes, right? See, now the drills are okay, alright? So in the solid verify rest material, you can see there is no rest material here apart from the outer boundary. So now it's a matter of shaping the outside, right? So now for the rest we can include another operation. as a profile, right? Position 2, alright, so that's fine. We have given the region to cut. Having that, we can select the tool, either any of the tool that we have selected. So we'll go with this. Upper level is this, right? And the profile depth is there's no need of offsetting now, right? Let's see how the geometry goes here. So this is pretty fine. Okay, so lead in as an arc and lead out in the same way. So now it has been machined, right? See the solid verify. Right, so it's only a short process. Right. So there is no rest material now, and the machine is fully the component is fully machined, right? So this is how we are to perform the solid cam machining, right? So it needs quite a bit of practice, right? So I hope there's an when we are so the first example is done, so the second is easy, right? So I'll make the next video on the example 3, example 4 and example 5. So till then, practice this first exercise and the second exercise, and if you all have any doubts, please email me. So finally, to generate the G code of this, right, so calculate all, simulate, solid verify, spotting, spot drilling and drilling, facing, right? So finally the block, final machining component, right? The machine component. So you can generate the G code here. So warning, this is not a production ready post and must be modified to the machine tool requirements before use, right? So that's okay. So here we get the G code of the machine we performed, right? So actually it is a matter of generating this code, right? And make sure you save it. Okay, so thank you for joining. Please do the exercise 2, 3, 4 and 5, right? So actually the first one and the second one, right? So and then we'll do the on the next session we'll do the exercise 3, 4, 5. Okay, thank you.